Okay, so yesterday we talked about optimization, which is a use of finding maxes and mins. Obviously, calculus can find max and mins by first or second derivative test, or finding where something is increasing and decreasing. That's the application of that idea. That's the optimization idea. Finding the greatest possible, or the least possible, to help you solve the problem. All right, so yesterday we focused on business calc. Today we're talking analytical geometry. Analytical geometry, I remind you, is just a fancy pants phrase for the mixture of geometry and algebra coming together. I know it seems like nothing to you because it's just handed to you, but the idea of having geometric shapes like this combined with equations to make those, that actually is a huge leap forward in mathematics that's only about 500 years old. It used to be geometry's over here, algebra's over there, and they never mixed. Analytical geometry is the idea that you can find equations or rules that make those geometric shapes. Now, anyway, in analytical geometry, or more like just the coordinate plane kind of equation, a rectangle is to be inscribed in a circle of radius 10. Now, surely I could make this a pure, geometry problem and just have some kind of floating semicircle problem and floating rectangle problem. But then the equations are hard to come up to. So instead, add in on top of it the coordinate plane. So instead of base times height kind of formulas or pi r squared kind of formulas, we have equations for those shapes. So in this case, for example, I would think put a semicircle on the coordinate plane. It would be very logical to center it at the origin. Radius of 10 is here, and then think about the rectangles that could be inscribed. Now, I could do many rectangles. This rectangle here with a really wide base and a really small height would have a very small area. You with me? In fact, as that height went to 0, the area of that rectangle would approach 0, yeah? As I grew my height, the base would get smaller, but I'm getting more area. And then different area. And then different area. And as I made my height bigger and my base smaller, I think the area would start to decay again. And I'm again approaching no area. So there's this sweet spot in there where there's this greatest possible area between 0 for a wide no height and 0 base big height. You with me? So the idea is, what is that greatest possible rectangle? Now, we talked yesterday about the first thing you should do if you're going to optimize something is identify what you're trying to optimize. You're trying to maximize what? Area, okay? Now, get an equation for that. You can't do calculus on area unless you have an equation for area. So what is an equation for the area of a rectangle? Not the circle. Let's maximize the area of the rectangle. Base times height. Perfect. Now, we put it on the coordinate plane. So we're going to replace base and height with x and y kind of stuff. What's the base? Okay, it could be up to the radius, but that would be all the way out. Our rectangle won't necessarily be all the way out to the radius. It could be something a little less. So base is horizontal distance. What do you think? X makes sense. So it's not x. It's 2x. Okay, because x is the distance from the origin to a point. We're going x to the right, x to the left. It's 2 x's, assuming there's symmetry, right? So, for example, if I did a rectangle from -5 to 5, wouldn't that base be 10? And so it's double that x value, so it's 2x. And the height, yeah, it's y. The height can vary. It's a lot of different possibilities, but it's y. All right. So the next step is to get an equation. Cool. What do we typically then do before that? Before we run a prime on it, or we try and maximize, we do substitution. Try and get down to 2 variables. What's another relationship? Now, at some point, you're always going to be asking yourself, are they throwing this circle in there to trick me, or am I supposed to use it? Well, you're supposed to use it. Okay. Any time I choose, say I used an x of 5, wouldn't the y then be forced to be something as a consequence? If I use an x of 5, wouldn't the y have to be something like the square root of 10 minus 5 squared, or the square root of 75? All right. So wouldn't you agree that for any x, there's a relationship to y via the circle? And the idea is that y is square root of good job reading. Somebody read it.
100
Keep going, lady.
minus x squared.
What the fuck? No, I'm so okay.
Those look like
I'm
two
gonna-
eyes.
No, they don't. I'm going to let you skip some on tonight's problem, just for speaking. For actually just reading what I wrote for you, you're going to skip problems tonight. Okay, good job. That's how exasperated I am with the silence of this class, all right? We all heard me say every word.
Nobody heard you say 100.
So if you were to use that to substitute in for y, then you get an x on the equation. Now, surely it's a little uglier now, but at least it's not three-variable calculus, which is a step forward. All right, so here we go. When I differentiate, do I want to know when dA dt goes positive to negative, or dA dx? dA dx. I want to say as x changes, how does area change, and when does it stop increasing and start decreasing? So I want to know when dA dx, or just the normal derivative, no time component, goes positive to negative for a max. So now let's go. The derivative. What derivative technique will I need to execute this? Product rule. I also probably need the chain rule on that second guy. Right? So first stays the same, 2x. What's the derivative on the square root of 100 minus x squared? Think of it like 100 minus x squared to the half power. So change. 1/2 times 100 minus x squared to the negative 1/2 times the inside derivative, negative 2x. Beautiful. All right. Plus, second stays the same, square root of 100 minus x squared times the derivative of the first. What's the derivative of the first? The first being 2x. 2. Wonderful. All right. Now, we want to know eventually where this is 0 or undefined for critical numbers, but we have some algebra to do. This is, you just do this probably 100 times during a calculus class, this calculation. It just happens a lot. So when you go to clean this up, I would probably make this 2x is fine, 2 in the denominator, square root of 100 minus x squared is in the denominator, and negative 2x is numerator. Sorry, that's numerator, isn't it? You follow? All right. Plus 2 root 100 minus x squared is 0 or undefined. I typically would take the sum and try and make it one big fraction. So let's get a common denominator. I'm going to hack a 2 out if you don't mind, yeah? So what's the common denominator? Root 100 minus x squared. Wonderful. This is negative 2x squared. It's fine. This guy you had to multiply by root 100 minus x squared over itself to get the common denominator, so it becomes normal 100 minus x squared times the 2 that was out front. So cleaned up, I'm getting something like negative 2x squared minus 2x squared more, so negative 4x squared plus 200 equals 0 or undefined. With now this would be undefined. A prime is undefined if x is, I'm having a little bit of trouble. This would be undefined if the denominator is 0, yeah? And what would cause that to happen? If x is plus or minus 10, yeah? Now with that, That's actually if x goes all the way out to 10. Now that's a critical number, but it's not a max area, that's a min area. If x is all the way out here, then that's an area of 0. So that's the smallest the area can get. The other possibility is a critical number because the derivative is 0, which would imply the top is 0. A fraction's only 0 if the top is 0, and that is at plus or minus 5, so we will just go with 5, all right? If that's a 0, or sorry, if that's truly a max, the derivative should go positive to negative there. So if I think about this, if I put in 1 for x, would this be positive or negative? Positive. And if I put in 8 for x, 8 squared is 64 times negative 4 would be 300-ish or 240-ish, that would be negative. So did I get a max at x equals 5? Yeah, all right. So that's a max because the derivative is going positive to negative. And so to answer the final question, does it say what is the greatest possible area or what are the dimensions? So they say what's the greatest possible area? X equals 5 yields the max area, but now we need to actually find the area. The area when x is 5, what is it? Let's go here, because that equation, rather than 2xy, which uses x and y, that one uses x only. That would be 2 times 5 times 100 minus 5 squared, 10 root 75, or maybe something like 50.
Mr. Rickman?
Yep.
5 wouldn't make it go negative. For the critical number?
You're saying it's the square root of 50. You're right. Sorry. I changed from 200 to 100 here. Thank you. Good point. Could have told me a little earlier, but I'm glad you spoke eventually. Thanks. When I went from here to here, I made a transfer error. I made it 100 instead of 200. Sorry, that was wishful thinking. It should have been 200 equals 0, so x squared is 50, so x is square root of 50 or 5 root 2. Sorry about that. That is a max still if I did the sign test, so we're good there. But that obviously is going to change the area calculation. Sorry, I need to put 5 root 2 into my area equation. A little bit grosser. That would be 2 times 5 root 2 times the square root of 100 minus 5 root 2 squared. So that's 10 root 2 times 100 minus 5 root 2 squared is 25 times 2, so 50. So I'm feeling 10 root 2 times the square root of 50, which is 10 root 2 times 5 root 2. So 50 times 2, or 100 is the greatest possible area. Okay, unit square. All right. So that's yet another idea, and I told you yesterday, I'll say it again. These problems are kind of all over the place. There's a lot of different varieties. They're not all the same. I know we're typically used to a problem being the same or pretty much just different by the numbers. These are all kind of different uses of the derivative. Last but not least, the point on the curve. Y equals 2 minus x squared nearest to 3, 2 is. I'll let you give that a go. See if you can identify what you're trying to optimize, if you can get an equation for it, and get to the answer here. I'll give you some leading questions, but I want you and your math amigos to try it. I might draw a picture. muestras de amigos de video de paso de video That's about it. What are you trying to maximize or minimize? This, do you have a math relationship with this one? Have you been talking? None for a while.
It's like quite slow. That's quite slow. This is only like t is equal to x squared minus it's like x minus x squared plus y minus x minus x plus or okay. So then it is x2 there's not we have two equations. We have to solve for what place? Okay, we have to plot denominators. Oh, that means 2 so we can plug in this because like we get to the denominator so what's another relationship?
Idea. Yeah, making good headway. Obviously, it's easy to just sit there and wait for me to do it for you. Of course, just lots of chance to prepare for college, because that's actually what you do in college. Do things on your own. Remember the idea in college is pretty much 1 hour in class for every 3 hours out of class. So it's mostly on your own in college. Get used to it. Practice. Yep. See the cube. That's not like fun. I agree with what you're doing. Honestly, rotates and check. Very rarely consult with your activities. Do you actually have to solve it? So I just go yes and check. Yes. Now, use the details. You know the points here too. So one of those that I used was, so I go with like something like x minus 3 squared minus 2. That gets cut out. Distance x1. So that's distance. So now you want to substitute. So yeah. Now what do you use that could be? Yeah, that's the elimination. So you use that if you're or what? Okay. If you're getting a cube in the derivative, that's probably on the right track, at least I'm pretty sure. The good news is that cube is probably pretty clean. You could even do a guess and check. So I'll catch up to. That's what I'm getting for distance equation really clean. How about you? Okay, great. Now be careful as your derivative. Let's go.
Why wouldn't it be?
Did I make a mistake? I might divide a 2 out of there. So 2x cubed plus x equals 6 minus 3 rather. Beautiful. All right. Now it's starting to freak out, and if you're in that uncomfortable, gosh, is that right? It feels like I don't want to go on if it's wrong because man, I'm wasting all this time, and that can't be right because they don't want me to have to solve a cube, do they? Yeah, they do. They kind of do. Now the good news is all that pre-calculus stuff that you learn because you work so hard to learn, you know, the rational roots theorem, and the Descartes rule of sides, and the least upper bound and the greatest lower bound. Unless you're going to be a math teacher, you don't use it very much. Okay. If I threw this class at BC, then they would just guess and check. They just say, boom, x is 1. Just guess. I mean, it's clean. The x is 1, makes it 0. Do you agree? Go there first before you do all that synthetic stuff. Okay. So x is 1 is your critical number. If you were to sign test it, you would see it is a negative to positive idea. And so x equals 1 implies that at this point on the parabola, here when x is 1, that's when the distance is at its minimum. Now let's just answer the question. 1, oh, this is beautiful. We didn't have to find the y. There you go. With me? Okay. Say what? Okay. All right. That is that. Set 51. Do you have questions on set 51 still? About 11 minutes. I know we went over the replacements already. I don't know if we finished everything else. 51 question. 18. Just the what? Anti-derivative. Okay. Sounds good. Okay. 18, anti-derivative, cha-cha-cha. Okay, this is very much a technique that gets overlooked. And it's one of those things, 1 to 2, where sometimes the more skills you have, it makes things harder. So it's tempting now that you know use of it, think, oh, maybe I should use of it. Well, that's the first objective would be to say, can I just hit it the way it is? And the answer to that should be no, because you can't just integrate parts of a quotient separately. But can you integrate parts of a sum separately? Yeah, so that should be your goal, is how can I make it a sum? How could you make it a sum? So you can multiply, so I have 2 schools of thought. Some say, couldn't you rewrite it as that and distribute? And the answer is sure, you could look at it that way. Another is, can you break that into 2 separate fractions? And yeah, either way, you'll get the same result. That is equivalent to that, and that's easy to anti-differentiate. X plus 2 C. Now be careful, because this you can absolutely split. But this, a sum in the denominator, you 100% cannot split. Okay, that's a no-go. You can't do that. And if you're thinking, well, yeah, you think just numbers here. 4 plus 1 over 3 is definitely the same as 4 thirds plus 1/5. That's true. But 3 over 4 plus 1, which you know is 3/5, is most definitely not 3/4 plus 3/1. That's correct. Okay, so a sum in the numerator can be split, a sum in the denominator can absolutely not be split. Right? Okay. Does that answer your question, Tyler?
Yes, thank
Okay, you bet. Any other questions on whatever this is? 51. Okay, all right, let me at least get you some advice and check your answers on the U-sub fund sheet, and if you feel like, all right, I want to go back and rework it, fine, but here are my answers to the fund sheet. Some of you are in the 7th hour, so you already know if you did that well, but one we did in class, 2, they told you what the U-sub was, so I'm not going to bother with that, but that's my answer. 1/6 times the quantity 4x minus 1 to the 3 halves plus c.
What?
It's not what you got? What you do? Oh, okay. You might start that if you're not sure. Part of it also be, is that equivalent to what I got? It might not be written exactly like I did, but it might be equivalent. So 3, they told you the U-sub. I have 2/7 x plus 1 to the 7 halves minus 2 times the quantity x plus 1 to the 3 halves plus root x plus 1 plus c. Okay? 4, e to the 2x over 2 plus c. Moving on to 5. Okay? Here they didn't tell you what to use, so I'll tell you what. If you didn't get the answer, then I would write yourself a note, use this u. U there was 4x plus 5. If you did this correctly then, 1/40, 4x plus 5 to the 10th, plus c. 6, I think we did in class, is warm up. 7, I let u equal 8 minus 3 theta. Now, you actually are going to get 2 negatives along the way. One negative you'll pick up from the du, but you'll get another negative because the inverse of n type of sign is negative cosine. Those 2 negatives actually knock each other out, so that's why you see a positive final answer. 1/3 cosine of 8 minus 3 theta plus c. This is just like we talked about here. 8, this could be split. If you put those separately over x squared over x plus 1 over x, then anti-differentiate. That's the key there. 1/2 x squared plus natural log of x plus c. It was not a use. Okay. Number 9. Or 9. I let u equal x squared plus 1. On the AP test, multiple choices, you might see 1/2 natural log, no absolute value. Does that mean that's wrong? Why wouldn't there be absolute value? Yeah, because it's squared plus 1 is positive anyway, so the absolute value would be superfluous. You could leave them off. You could even possibly see a choice of that half being brought up. You might not see that or the absolute value. You might see this. It's pretty common when you get a log answer that they will use log rules to rewrite it. So you need to be very solid on your log rules for multiple choice choosing. 10. I let u equal sine of x. Actually, I used an identity first. Cotangent I rewrote as cosine over sine. Then I used a u sub, u of sine, and that's log of sine plus c. On 11, I let u equal 3x plus 8, which allowed me to distribute later. This is the way I wrote my answer on my paper. I don't do a lot of simplifying. I usually leave it ugly. 1/9 3 plus x plus 8 to the 13th over 13 minus 2 3x plus 8 to the 12th over 3 plus c. This, by the way, came from reducing. I think this was 8 over. I think it was 8 over 12 originally. That's where 2/3 is coming from. Or something equivalent. Number 12. I used a u sub because you do have a derivative as a derivative kind of thing. U of 1 plus cosine of 4x. And the antiderivative then is negative 1/16. 1 plus cosine of 4x to the 3 halves plus c. 1/16. Oh, is it 1/6? It's entirely possible I copied my answer. Oh, yeah. It looks like just a little stray mark, 1/6. Yes, you're right. It's not 1/16, it's 1/6. Thank you. You're correct. Okay. 13, change a variable. So in these cases, I'm telling you what the u sub was, but I'm also telling you what your new integral becomes. I remind you, when you do a definite integral, not only do you u sub the integrand, they call the thing that's in the integral the integrand, but you should also be changing the limits of integration to fit u. The beauty of that is, though, that you don't sub back in a definite integral problem. You anti-differentiate and you actually plug these in for you to get your answer. In a definite integral problem, you don't sub back. So I got 277 over 2. Do you agree? You got 277? Oh, okay. 14, u is x squared plus 9. My new integral then goes from 9 to 25 for u limits of root u times du over 2. My value then is 98 over 3 if you reduce.
Isn't it? Can you go to 146? It's 544.
So let's go. Do you agree with
No,
this?
not that.
This one?
13.
544 over 4? Over 4, right?
Yeah.
Did I divide badly? Is 544 over 4 not 277 over 2? 272 over 2. Oh yeah, I reduced that. So this should be 272 over 2, which is 136. Is that better?
Yes.
Okay, sorry, you're right. Okay, so that was an error. All right, 15, I made a u substitution of cosine. When I substituted, then I get an integral from 1 to 0 of u cubed, and my d is actually negative du. If you integrate that, though, you're eventually going to get a minus a negative, which is a positive 1/4. 16, this is my u, and you might have arrived after integrating at something like this: 2 log of 17 minus log of 2. But by log rules, that's the same as if you put this together in division. 2 log of 17 over 2, which then you could bring up, and so that's where that answer comes from. Okay? The last answers are D, A, C. Did I get to it all? No. So close. Here's that guy. D, A what? D, A, D? No, that's right. No, that's wrong. Totally wrong. Definitely DAC. The last ones are DAC. Make sure I get 51 today, and
Why would it be negative?
because E is, that's, so did you let U equal X cubed? Yes. So doesn't that mean that this is 1 over E u to the U?
Yeah.
So that means you're integrating E to the negative U. So you shouldn't have let U equal X cubed. You actually should have let U equal negative. So it's E to the U. That's a gotcha. Is this due? I feel like
So you're on the top floor, fifth floor. You go to
I can turn it in.
turn it in and then we'll go over it more.
So then you're second.
Oh, my bad. Sorry. Fox tune.
It's the same as it normally is.
It is? That was about fifth hour.
Yeah, well, yeah, that's not what I meant.
Oh, you mean the floor stuff?
Yeah, the first floor is second floor. Fifth.
Have a lovely weekend.
Okay, so sad that
51's definitely due.
Wait, can I turn?
And the fun sheet too. That would be great. What do you think? Fun sheet or no? We're not done. I didn't say. I'll take it or not take it. I'll take it Monday too. Have a lovely day. It's just you and me, Miss Harrelson, at this point, so whatever. All right.